Welcome to the HC Commodities Podcast, a podcast dedicated to the commodities sector and the people within it. I'm your host, Paul Chapman. This podcast is produced by HC Group, a global search firm dedicated to the commodities sector. Today we're talking about the complexity of the energy transition and how that complexity leads to different understandings within the public, within industry, and even within academia. However, for the energy transition to be effective, it's crucial that the rigorous analysis is done and that myths can be dispelled. Someone who spent a career investigating life cycle assessments and net energy analysis, renewable energy and energy systems, particularly around transportation, is our guest Marco Raugei. Marco is a senior lecturer and researcher at Oxford Brookes University. He is an environmental scientist with a PhD in chemical sciences, and there he teaches energy and life cycle assessment, and has spent his career focused on many of the topics that we've discussed in this podcast. As always, please do leave us a positive review on the platform you're listening on, and I hope you enjoy this fascinating episode. Marco, welcome to the show.
Thank you for having me. It's a pleasure.
So I'm looking forward to this discussion. We're essentially going to lean on your lifetime of work focused on the energy sector and how the systems work and so on, and working up to an understanding of where we actually are in the energy transition, some of the accelerators, some of the decelerators, and some of the myths. But I guess before we go too far, it'd be great to get an overview from you about your work to date and what you specialize in.
Yes. So my work to date is broadly speaking in the area of sustainability, and I have focused primarily on the energy sector, but also more recently, for the past 5 years or so, I've been doing work on transport, sustainable transport, and also on the built environment sector. All of these conventional sort of parcelization and categorization of the various sectors are just a formality, really, because the sectors overlap more and more. And going forwards with the increased rate of electrification of many sectors, which is as we can get into that, but it's definitely a welcome change and a good strategy to improve sustainability, or our chances of being more sustainable. Then the energy sector, permeates all other sectors. And in terms of the type of work that I've done and that I continue doing, it's essentially sort of high-level scenario analyses and assessments using tools such as life cycle assessment, net energy analysis, and the like, material flow analysis sometimes when appropriate and when it's the best tool for the job, to essentially assess a range of what-if scenarios, starting from the self-evident acknowledgement that no one can predict the future, but we can be rigorous and consistent in comparing alternative futures, alternative scenarios, and attempt to ascertain which of these alternative scenarios is less unsustainable. And I choose my words carefully.
Yes, yeah. And then that's how we came to have you on the show, because we had Kingsmill Bond on recently talking about, in his view, the energy transition is happening. It's happening faster than people realize, and it's essentially unstoppable. And on this show, we've had, multiple viewpoints from within the sector and some from without around the energy transition. And yeah. There is and I kind of want to talk about it a little bit. There's sort of one of the challenges that I perceive here is that actually there is sometimes a lack of rigor behind statements, behind systems, behind expectations. And
I believe so, yes.
Well, and almost to the point where some camps have more of a religious belief than they do a scientific understanding.
Unfortunately, that's probably the case. Yeah.
Well, I'd like to get your comment on that about, how is that? I mean, that is ultimately to the detriment of, accelerating least bad pathways, to use your terminology.
Yeah.
And it's also a challenge, and I think, and there's a lot of concern on this as well, quite rightly, the gap between the public expectations and understanding and the reality as well. Can you just sort of talk a little bit, I guess, on more sort of the challenge of passing that?
Yes, it's quite complex, to be honest, and therein lies the challenge, because, or at least one of the challenges. So there is a temptation, there's a tendency, if you will, that's quite prevalent across different. I think it applies to some extent to most people, to oversimplify and to attempt to formulate a simplified sort of message that fails to correctly or adequately take into account the complexity of the situation. And to add to this problem, which is a problem in and of itself, there's also some, we're all guilty of this again to some degree. I'm not, claiming any higher moral ground here, but there is, always a degree of preconception or preconceived ideas that we set out to corroborate with evidence that we cherry pick in order to fit our preconceived narrative. And this is, a temptation that we must resist. And my life's work, if I can put it in those sort of semi-grand terms, especially of late, the recent years, when I've become more and more keenly aware of this state of matters, it's been to try and redress the balance and try and strike some sort of middle path between these sort of extremes, if you will, or these polarized positions, which I can summarily describe as, on one hand, the technological optimists who simplify the predicament that we're in terms of environmental degradation and not only the climate change, but all sorts of other challenges that we face, such as a dramatic decrease in biodiversity, plastic pollution, and depletion of resources, depletion of phosphorus. I can go on and on. So there's one faction, if you will, or one camp of vocal advocates for new technologies, renewable energy technologies, that tend to champion those as sort of silver bullets to solve all of our problems. And in so doing, they banalize or fail to fully account or entertain the complexity of the predicament that we're in, and end up, perhaps, I say perhaps, but I'm convinced that that's often the case, oversimplifying the message, which ends up being something along the lines of, if we ditch fossil fuels and transition to renewable energies, all will be good, and we won't have to question anything else, or we won't have to question our expectations in terms of economic growth, in terms of our way of life, in terms of our exploitation of other material resources, because an abundance of affordable renewable energy will solve all our problems, all our ailments. So that's what I would describe or characterize as the overly optimistic, technological optimistic argument or set of arguments. On the opposite side, though, there are those who, perhaps, often coming from different backgrounds, and to be fair, there's it's not like a monolithic group of people. It's a motley crew of people and authors from different backgrounds, some of whom have some training in system sciences and ecology and see the world from a different perspective, and some of those people and authors claim that ultimately all of these new technologies, promising though they may seem at first sight, are a false hope, because they only continue or enable us to perpetuate and continue our relentless destruction or plundering of the planet, of our environmental resources, and ultimately it will make little difference whether we use fossil fuels or renewable energies. It's just by virtue of using energy and keeping our use and demand for energy unchecked, we will inevitably head down a path of destruction and unsustainable degradation of natural environment, and ultimately undermine human societies and systems as well, and economies and everything. And so we're essentially doomed no matter what we do. And so I think I spent a few words criticizing the technological optimists as being possibly too optimistic about the prospects and the benefits brought about by renewable technologies. But I should, to provide some counterpoint to that, I think it would be only fair to also describe and characterize this latter group of people as unnecessarily and excessively pessimistic, the doom and gloom camp, if you will, because in simplifying the message in their own way, i.e. in discounting the potential of renewable technologies to make a difference, and in claiming that essentially our choices in terms of which energy resources we tap or which energy resources we turn to as the main supplier of energy to all of our processes and societies essentially makes no difference, and it's inconsequential, and it's essentially only a distraction. I don't believe that to be the case. I think there's solid evidence to show that there are ample margins for decreasing the pressure on the environment. And of course, this may not be enough. It probably won't be enough in and of itself. It will have to be eventually accompanied by some soul searching and some more systemic rethinking of how our economic systems are working. And so there is some truth in what they're saying in terms of it will not suffice to replace fossil fuels with renewable energies to solve all our problems. But where I think the message is then twisted and made, and then no longer correct, is in dismissing the energy transition as a futile distraction. I don't believe it is a distraction. I think it's our best bet, our best chance to improve the situation. But it may still not be the be-all and end-all of sustainability. It may still not be enough. We will probably also have to reconsider our expectations in terms of endless, unbounded economic growth and other aspects that are rarely mentioned in the same sort of breadth, in the same discourse, because they're unpalatable. They're not easy to accept by most. So I think, again, I'm trying to strike a balance here, as you may notice. And I think, and unfortunately, another problem, and then I'll give you back the word. Obviously, I don't want to monopolize everything here, but I think part of the problem is that a more nuanced message and something that, something akin to a middle of the road or middle ground position is less appealing to most people because of our innate preference for simple messages, clear-cut answers. It's good, it's bad, it's doable, or it's not doable. We're saved, we're doomed. That kind of black and white view of the world is much easier to sell, much easier to attract consensus at first sight. And I think we should, grow up a little, everyone, and resist this temptation to oversimplify the message and accept that both camps or both sets of arguments may be simultaneously true to some extent, while there may be flaws or limitations to both arguments. And So again, complexity is the name of the game, unfortunately, whether we like it or not. And reality will then, will then take its course, regardless of what we would ideally prefer. Yeah, so that's kind of a brief, well, maybe not so brief introduction to my thinking and what I've been trying to do in my work is to stay very grounded in terms of not making too many assumptions and being diligent and careful in my assessments, in my to the extent that I've been able to in my scenario analyses, and always being very upfront and honest and transparent about the limitations of the studies or the assessments that I've taken part of.
Yeah, and I want to cover a couple of those assessment categories, but there's so much in what you say there, that complexity, and some of it starts with that definition of sustainability, and I kind of have this somewhat feeling that it served a lot of camps to conflate climate change, i.e. greenhouse gas emissions, with environmental degradation historically, because by denying the former, you could get away with the latter. And,
Yes.
and now we face a situation where both are, one is, climate change is obviously an immediate global impact. The results of environmental degradation, loss of biodiversity, microplastics, is a much more pernicious and long-term and harder to quantify in some senses on a global scale. But that conflation is historically rooted and causes a lot of these challenges. Mm-hmm. And it's that word sustainability where you are in a sense balancing lots of different lenses there. Are we seeing in this approach, is climate change, greenhouse gas emissions seen as the existential threat, and therefore we are willing to sacrifice on the environmental side? And we've discussed this on the podcast a number of times. You see that with essentially where the battery supply chain sits in China.
The extent to which climate change may be considered the most pressing existential threat is debated. I personally believe, based on what I've read, and it's not, I'm hesitant to use the word believe because I don't want to make it sound like, again, a religious belief or something that is untethered to evidence. I try and always remain, as I was saying a minute ago, rooted and grounded in evidence, in data, in information that is scientifically robust and proven beyond reasonable doubt. So I think there is evidence to point to the fact that climate change is a potential existential threat. And I say potential because I think with all the uncertainty involved, one should be sensible and apply the precautionary principle. So we shouldn't wait until we have absolute certainty. Absolute certainty is something that appeals to the layperson, but is anathema to science. There's no such thing as absolute certainty. There are only degrees of uncertainty, and so even models that are indicative of a significant percentage of likelihood that we may be headed for, say, a climate tipping point beyond which many parts of the populated continents would become uninhabitable or hard to survive, should be plenty of reason enough to act on this threat without dithering and waiting for more certainty, because certainty may never come, or if it does, it may be too late. So climate change is definitely, I would say, and I'm not alone in this. I think there's a sizable majority of the scientific community that agrees that climate change is one of the main existential threats. However, I don't think it's a matter of either or a matter of addressing one to the detriment of others. I think it's more a matter of attempting to be holistic in our studies, assessments, and considering the threat posed by climate change alongside other threats. For all its limitations, for example, and it has been criticized as excessively qualitative in its framing, and to some degree, those criticisms are founded. But the work done by the Stockholm Resilience Institute and colleagues that resulted in this whole planetary boundaries framework, I think has value in broadly, coarsely, if you will, identifying the main areas where we may be trespassing such boundaries, the main types of environmental degradation, environmental issues, and how far are we down the path of going beyond those limits that the biosphere, the planet, can safely function. So yeah, going to some more specific examples, I think there's also some misinformation being spouted and parroted around about the supposed unsustainability of some of the key technologies that are being developed as part and parcel of the energy transition, such as photovoltaics, wind energy, and electrochemical storage, i.e. batteries. Of course, all of these technologies have their limitations and also have their share of environmental impact, primarily to do with the demand for what I refer to as critical raw materials, right? Mostly metals, but not only metals. And for sure, there will be associated impacts in terms of toxicity and environmental disruption due to mining and refining of said critical raw materials. And these environmental impacts are in different categories, or if you will, along different axes relative to climate change. And a single, tunnel vision approach on climate change alone may in fact miss some of these other threats, potentially also existential threats in terms of our sustainability. However, I think what is missed by often, no, I won't say always, but often, by those who raise these issues to everyone's attention and use them as arguments against renewables, or as arguments to somehow support the notion that renewables, the cure is worse than the disease, in terms of, renewables are even worse than fossil fuels, because on one hand, they may have lower greenhouse gas emissions and help us towards, addressing climate change, but then they're far worse in other respects. I think that is disingenuous to a if you actually look at the information and the quantitative material flow information, the amount of environmental disruption associated with mining these critical raw materials for these technologies that I've just mentioned and others to do with the renewable energy transition. So the amount of mining associated to all of these elements, even in these projections where these technologies continue to grow exponentially for a decade or two, this is relatively minor. It's actually almost minuscule compared to the routine environmental disruption associated to things like coal mining that we've been doing for decades and decades and decades, actually a couple of 100 years. Obviously not at the scale that we're doing it now. And so if we manage to displace and reduce the demand for conventional fossil fuels by a combination of two factors, deploying more renewables and electrifying all sectors, so that the same amount of useful work is done with a comparatively smaller, significantly smaller demand for primary energy, then we will have accomplished a net reduction in environmental disruption also along those other axes, not just for climate change. So it really is, in most instances, a case of a win-win situation whereby the energy transition helps across the board to reduce environmental destruction. So I wouldn't frame it as a either or situation, but more as a
Yes,
one
and
hand, yeah, yes, and yes. But of course there are limitations. Of course there are caveats. Of course we should be careful, and we shouldn't, dismiss or fail to take into account all of these other impact categories and these other types of environmental impacts.
yeah, I mean, and you hear these arguments distilled down and used as talking points, and already it's very prevalent in, my wife won't mind me saying, my family in northern Texas, and so forth, who are, well, EVs are worse for the environment than my F-150 truck. But that aside, the other
Yeah, there's a lot of misinformation or lack of information, and also more often than not, lack of willingness to learn. Actually, I'm sorry, I don't want to sound.
there aren't
Yeah.
also to be fair as well, there aren't also the channels to learn, depending
It
on where
is.
you live.
It is. Yeah. It is. It can be challenging. Yeah. Yeah. It can be challenging to sort the wheat from the chaff. To sort. Good. We're all swimming in this ocean of information. To be fair, today, like never before in history, and everything is at our fingertips. Almost everything. I mean, there are paywalls and there are limitations to what you can access, but you can access a lot of information
But
nowadays.
you need to be
You don't know
tools.
where to look.
Yeah, and you also need to have the tools to be able
To make sense of what
yeah.
yeah, sure.
So that first one, that's an elegant explanation of some of the myths around sort of the renewable systems. The second one, of course, and I know you get a bit bored of this subject, but I think it's an important one. Is obviously EROI, EROI,
Yes.
energetic return on investment, and just to quickly frame this argument, is essentially the amount of energy put into an energy producing system versus the amount of you get out, and the prevalent argument, and we've had panelists or speakers on this podcast espousing this point of view, is that essentially renewable systems yield much less free energy than conventional hydrocarbon systems, and therefore in order to deploy them, we're all going to have a commensurate standard of living decrease as well.
Yeah.
Can you talk about your work around that?
I mean, in a nutshell, I disagree with that statement. I think there's mounting evidence to support my point of view. But to elaborate a bit more and explain why I disagree and why it's not quite as simple as it may sound, again, it's a case of deceptively simple metrics and that deserve and actually require more nuance in their application. Energy return on investment, as you rightly said, is the ratio of the energy provided by a supply chain, say, over the energy put in. When put in needs to be explained as the energy deliberately invested in the supply chain, not the energy harvested from the environment or stripped from the Earth's resources. That's not included in the calculations. Okay. Historically, the first systems that were subject to this sort of assessment were oil fields, and it's fairly intuitive. You need energy in order to bore a hole in the ground and to pump up the oil, but then the oil that you get contains more energy than the energy that was required to extract it. And if the ratio of the energy in the oil versus the energy invested for its extraction is approximately, historically, may have been higher than 100, today probably around 20 or so, you have significant advantage in terms of the energy returned or given by the system over the energy invested. That's all good and well, and simple enough, it would seem. But the problem is that not all energy forms are equally fungible and equally, interchangeable. Good luck trying to have this conversation using computers and microphones, etc., if you only have a barrel of crude oil, because you can't feed the crude oil to the computer, right? You need to use electricity at the correct voltage level, correct frequency for the appliance to work. And likewise, you can't even drive your car using conventional internal combustion engine car using a barrel of crude oil. You have to refine that oil into petrol or gasoline for our American viewers, and that requires additional energy investment that has to be purposefully and deliberately diverted from other possible uses in society just to carry out that refining and then transporting the fuel to the pump and so on and so forth. So that's a bit of a long story to say that in order to compare different energy sources, we should really be focusing on the stage, the point along their supply chain, where the stage along their supply chain, where they become interchangeable, when one can be replaced with the other, when one can displace the other. And that depends on the application. So there has been somewhat, in the somewhat recent past, let's say past 5 or 6 years, there have been a number of key scientific papers published that have shone a light on this issue and that have raised attention to the importance of comparing like with like in EROI, energy return on investment assessments. And one of such papers just happens to be co-authored by myself, and it's a review paper, a harmonization paper, where we looked at previous literature and tried to make sense of the disparate numbers and how they can or cannot or should not be compared. But another paper was published in the very reputable journal Nature Energy in 2019 by colleagues here from the UK, Brockway et al. And a follow-up paper to that was just published this year, again in Nature Energy, where essentially what they did and we did to some extent also, albeit in the form of a review rather than a new original study, is attempt to set the playing field level and include all of the energy inputs, all of the energy investments that need to happen in order for different forms of energy, different sources of energy to become usable from the point of view of the end user. And so you have the supply chain, transportation, pipelines, refineries, all of the steps along the supply chains of fossil fuels. And on the other hand, you've got the renewable generators, solar panels, wind turbines, and whatnot, hydropower dams, which also need to be constructed, maintained, and then the electricity needs to be conveyed by way of transmission lines and whatnot before you can actually use it. And then, only then, when you get to the point where you're tapping the energy resource at point of use, be it at a socket in your home or at a charging point for an electric vehicle or at the pump for a conventional vehicle, then you have something that you can start comparing. And then there's an additional element, additional spanner that needs to be thrown in the works before we can make a sensible comparison and before we can have a sensible discussion about this whole EROI mess. And that is the efficiency at which the energy carrier, to use a technical term, so the fuel or the electricity, is used and converted into useful work. Because nobody in their lives needs energy per se. They only need energy insofar as that energy allows them to do something. And this do implies work. So it's either transport myself and my family or my goods from point A to point B, and that would be traction energy, or better stated, transportation services, or some other sort of electrical service, such as running computers, lighting, fixtures in buildings and on roads and streets and cities, providing heat to industrial processes, providing lifting energy, lifting power, for cranes and construction appliances and facilities, etc., and so on and so forth. So depending on the specific use case and the devices where the energy carrier is used, you have potentially radically different efficiencies. And so you shouldn't just compare the EROI of crude oil to, say, the EROI of wind electricity, but you should compare the EROI, if you will, at the useful stage of providing a transportation service using a conventional car that runs on gasoline, which requires refining of crude oil, which was originally extracted at a certain EROI, versus, say, an electric car that runs on electricity, which is provided by a battery, which needs to be produced with an additional energy investment, and which is recharged using electricity potentially produced by a wind turbine. So that's a far more complicated assessment, but it's a more meaningful assessment and comparison if we are to estimate, the extent to which a shift from one set of energy resources to a different set of energy resources may or may not entail a change, reduction, or increase in standards of living.
And what is
Again,
that?
It's complicated.
Yeah. And what did that picture tell you from those recent
Well,
studies?
that picture tells us, these recent studies tell us that the simplistic, if you will, message of conventional fossil fuels having a very high EROI is not false per se, but very partial, and therefore misleading, because most of the assessments to date in the literature, and those numbers that continue being tossed around by many people artlessly or deliberately, tend to be partial assessments that only focus on extraction. And so instead, when you follow the energy carrier along the entire supply chain and get to the useful stage, you realize that by the time you get there, the tables have turned. And in many cases, I won't say most or all cases, but in many cases, the energy return on investment at the final stage of renewable energy sources ends up being actually higher than the energy return on investment of conventional fossil fuels. That completely subverts the narrative that you were referring to before. There are caveats, of course, there are limitations, and there are still uncertainties as to the degree to which these results can be extrapolated and extended to the entire energy system, because all of these numbers are, fossils and renewables alike, are calculated by necessity based on case studies and relatively reduced scope analyses. And so there are extrapolations, there are attempts to extrapolate to the large scale, including those two papers that I just mentioned, but there are uncertainties remaining. And so we should always take everything with a grain of salt. But I think that, the gist of the message is that.
I'm tempted to ask, where does hydrogen stack in?
Nowhere would be my answer, for the simple reason that hydrogen is not an energy source. It's only I would consider it an energy storage medium, something akin to a battery. Like, you've got energy, you can feed it to a battery and store that energy for some time. or to retrieve it later. Likewise, you have energy, be it in the form of fossil fuel or electricity produced maybe sustainably using renewable energy. And you can use that energy or part of that energy to generate hydrogen typically by splitting water. Or you can reform the natural gas directly. But if you do so, then you have significant emissions of CO2. And so you're probably better off just burning the natural gas in the first place. But if you produce hydrogen sustainably, quote unquote, i.e., what's often referred to as green hydrogen or purple hydrogen, respectively, using renewable energy or nuclear energy, then you have a low carbon fuel that you can then use, but it's not really an energy source. It's something that you had to manufacture, that you had to produce in the first place with associated losses. And so it's only, again, it should be discussed in the same breath as batteries, really.
The energy and resources sector is experiencing unprecedented change. To help companies navigate this world and capture its opportunities, HC Group launched Enco Insights in 2023. Enco has rapidly become the leading global expert network dedicated to energy and resources. Enco Insights leverages HC Group's 20 years of connections and dedication to the sector to give clients the expertise they need to take decisions fast. Connect with Enco's experts for anything from a 1-hour insight call to a longer-term consulting project at encoinsights.com.
For the most part, we haven't talked the economic aspect of this. And one, question or one point that keeps coming up in this podcast by some of the leading thinkers in the commodities sector is we are straying away from market-based solutions that have historically, because of the nature of the way humanity works, have been really important in
but they've never
change.
Worked.
well,
They've never managed to solve the problem.
Well,
why would they work now?
Yeah, so and I think the simplistic comparison is often made with sulfuric acid and acid rain and the catalytic converter, solving that in the wake of a tax, a price put against sulfur, which is where I'm leading up to my question. And it seems to me that's just not possible in carbon. But what is the view, I guess, your view on how we try and put a price on these externalities to help decision making?
I mean, that's a tool or an arrow in our quiver, and we should definitely use it. I mean, I think there's a role and there's a place for economic incentives and economic tools, such as a carbon tax, such as and they can nudge the system in the right direction. They can contribute to shifting the balance more in favor of technologies and options that are more sustainable or less unsustainable, for sure. Having said that, I think that putting all of our eggs in one basket and blindly trusting the market to sort itself out is a bit of wishful thinking. And I think the reason I say this is that it's twofold, really. On one hand, I think those examples that you mentioned, like sulfur or the CFCs, the Montreal Protocol for the ozone hole, those were relatively low-hanging fruits. Things for which replacements could be found fairly easily. It was just a matter of providing the right, a sufficient nudge or a sufficient incentive to redress the balance, and then everything else fell into place. And even so, it's taken a while and it hasn't been smooth sailing. But yes, maybe market incentives and that sort of tool could suffice for those. I think what we're facing now is a far more systemic, existential predicament where we need to address, the problem more again systemically and I think only relying on market instruments is probably not going to cut it. And I say this not as an economist, and I don't want to claim expertise where I don't have much. So I don't want to get too deep into the discussion of economic measures and incentives, because that's not my home turf. But my perception is that, useful as they may be, and they certainly are, there's probably more at stake, and there's more. We will need a more fundamental rethinking of our economic paradigms than just slapping a few extra taxes here and there.
Yeah, yeah. Well, it's probably unlikely to happen, even if we do, as take
Absolutely,
global
yeah.
coordination. So I guess in the last few minutes, rather
Yes.
rather than dig into specific scenarios and so forth, it'd be great to get a sense from you, kind of, what do you think would accelerate, and I hate to say, not necessarily the energy transition, but better decision making around the energy transition, whether that's by policy or indeed, I guess, the realm I'm more involved with, which is by corporate action. What are those key things there?
Well, I think, I mean, like your former guests argued, I think the energy transition is already underway and ultimately will be unstoppable, for a number of reasons, not least of which because it makes economic sense. How do we speed it up, or how do we, facilitate it further? I think, and again, I'm not claiming that this is necessarily going to happen, because I'm keenly aware and painfully aware of the lack of systemic thinking everywhere, and especially at the policy level. But a bit more systemic thinking wouldn't go amiss, rather than just focusing on individual technologies, individual issues, individual incentives, individual this and that. Looking more at the systemic level, and how, the extent to which we can drastically, increase efficiency overall across the board and reduce wastage of energy. And the energy transition is related to that. I'm not changing the subject, because by transitioning, we are sidestepping one of the main roadblocks to efficiency, which is thermal conversion of fuels into energy, in thermal processes. So it's thermodynamics 101, that whenever you have a fuel and you burn it to power anything, be it an engine or steam engine or a turbine or whatever, you're essentially throwing away 2/3 of that energy, never to be recovered, and that energy ends up being dispersed as heat in the environment. So incentives towards electrification everywhere, which are already underway, but which could be, further incentivized. I know it's a bit of a recursive definition, but it would definitely be a step in the right direction, because you're shifting away from fossil fuels and shrinking the demand from primary energy at the same time.
Yeah.
Demand side management also. Yeah. Again, avoiding wasting resources and energy just because we're using energy in a very wasteful way would be a good thing. And that also helps the energy transition, because there are limitations to, despite the exponential growth in technologies such as wind and solar, that there's limits to how fast they can grow. And so if you help them by, reducing the demand without necessarily reducing the standards of living, but just by doing things the smart way rather than the dumb brute force approach way, that would help. That would go a long way. So obviously the system will become more complex, not less, inevitably. And that's also a risk in and of itself. And this would lead us down a different path and a different topic altogether, which is related, obviously, but which may not be the right place and time to discuss that. But there's a degree of risk, and as societies become more complex and potentially more brittle and less resilient, and that's a risk that we'll have to take.
What do you mean by that? Is that because essentially electrons don't travel like molecules, and so you
what I mean by that is that if you have, think, I'll give you a case in point, an example that will make it clearer, I hope. Like a conventional, relatively primitive, if you will, grid mix, electricity grid mix, may, for example, comprise coal and gas. And you have coal that provides constant output 24/7, which is often referred to as the base load provider. And then you have gas, which you can regulate, you can modulate the output of, and it can be used to follow demand to some degree. I'm simplifying a lot, and those who are experts in grid balancing would start tearing their hair out. But in principle, that's a fair simplification, I would say. Now, those are both technologies that you can control easily from the top down, and you just follow the demand wherever it may go. And if there's more demand for electricity, you ramp up the gas turbines. If there's less demand, you turn them down, and then the coal power plants continue providing.
Essentially our grids, and we have actually covered this, of course. It's hard, all of the way they're set up in terms of maintaining that frequency becomes challenging. I guess also, though, to sort of, guess my initial thought was you're essentially also ever localizing energy systems as well, right?
Yeah, so you're ever localizing them. You require more real-time bidirectional control over how much energy is delivered where at which particular node in the grid. And if you also try and help the system by managing the demand, micromanaging the demand with demand side management measures, etc., then you become reliant on all of these real-time energy meters and all of the, and if you want to integrate the transport system with the energy system and provide electricity back and forth to and from the grid via things like vehicle to grid energy storage to complement and help renewable energy generators, and then you become even more reliant on the micromanagement of all of these individual distributed storage systems and generators. So all of that is far more complex and requires far more,
micromanagement regulation,
and infrastructure regulation technology, and everything will be obviously, you cannot possibly run any of that without supercomputers or computers that control everything. So obviously it would not have been doable, decades ago when we were happily using electricity at the beginning of the 20th century, right? So already, but so the systems become, in that sense, a bit more fragile, a bit more brittle, because a lot of things can go wrong. But at the same time, you can
lots
also
of opportunity, right?
Exactly, there's lots of opportunity.
And I also find that fascinating. You bring in the demand piece side, and I talk on, I guess, with a lens of the energy trading world, right, who are very good at solving just these types of problems. So there's a huge opportunity there. And electricity itself today is becoming more real time. The curve way dated out over a few months is much less important today than it is about, the day ahead. The other thing that always strikes me is, with this electrification of everything, which, as you say, just, prima facie on laws of thermodynamics, it makes a lot of sense. That will fundamentally change as well how we think and build the infrastructure that we use, right? I mean, you get these comments, well, how would you ever be able to power semi truck or a huge dump truck with a battery? When the answer is it might the transport of the future might not look like that, right? We might be better off with 100 little dump truck drones than one big enormous one, right?
And it's already happening in many. I mean, many of those who point to, say, heavy industry as impossible to electrify, honestly, they seem to be a bit out of touch with the latest developments in the industry, including the mining industry. There are huge pieces of equipment already being electrified, whether it be using batteries or by simple cable connection to an electricity grid mix. Already, there's the mining sector in Chile, for example, is being electrified because of abundant and growing availability of renewable energy, and specifically solar photovoltaics up in the Atacama Desert and whatnot. So, I mean, these things are happening. And as you say, I mean, I agree, the future need not look like the past in all of its components. What we need to focus on getting the job done rather than in replacing like with like along every single link of the chain.
Yeah. Well, Marco, it's been fascinating, and I hope we can have you back on again shortly and perhaps take part 2 and talk about the some of the future aspects of this and dig into that.
Thank you.
I think it's fascinating to go through those scenarios. So we'll get that one in the diary, and I really appreciate you coming on and I guess helping us with some of the philosophy, but also some of the critical thinking around the energy transition.
Thank you very much for having me. It's been a pleasure.
Thank you for listening. To find out more about HC Group, our global offices, and our expertise in search within the commodities sector, please visit www.hcgroup.global.